Hello guys, I'm back. Today I'll talk to you about the influence of flow measurement in your heat and material balance when you are performing your process simulation, and also in the development of a piping and instrumentation diagram. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to get hundreds of contents related to chemical process engineering and plant design. During the development of a project, it's normal to not add the flow measurement devices in your process simulation because in the early stage of the process of the project, we didn't define what is the kind of flow measurement that will be used in the project. However, depending on the kind of the flow measurement that you are using, they had different pressure drops associated with the flow measurement, and that can have a great impact in the results of your process simulation. For instance, if we are talking about a thermal mass flow meter, the pressure drop in this kind of device is negligible. So you don't need to add the pressure drop associated to this instrument in the process simulation software. However, some flow meters like Coriolis, that is a mass flow meter type, can have a big difference in your process simulation because depending on the conditions, the pressure drop can be as high as 1 bar. And if you forget or not consider this 1 bar in your process simulation, that will lead to a lot of differences. For instance, if you are designing the discharge of the pump, 1 bar of differential pressure can represent 10 meters of column of water, and that will impact the performance of your pump when you are selecting the best pump for your process. If you are dealing with a compressor, you will have the same effect. For a centrifugal compressor, the performance curve is very similar for centrifugal pumps curve, and you will have more pressure drop in your system, and based on that, eventually your equipment will work with a higher pressure but with a lower flow, and that can impact, that will have a negative influence in the performance, in the production of your process. So when you are dealing with the heat and material balance of your process and you are using the process simulation software, you must be alert to review your heat and material balance to make sure that this kind of component is considered or not in your heat and material balance. Once the heat and material balance is finished, we develop the process flow diagram, and from the process flow diagram, we do the development of the piping and instrumentation diagram, where we need to indicate the location of the flow meter installation. The pipe instrumentation diagram is just a schematic. It do not represent the real conditions or the real coordinates of a project, but we need to add the flow meter in a position where the pipe designer can identify where it will be in the discharge of a pump, in the suction of a compressor, downstream of a vessel separator, and etc. And again, the selection of the flow meter not necessarily is a responsibility of the chemical process engineer, but eventually you will face this challenge. And there are many flow meters type available in the market. I will not cover them in this video. But what I would like to bring to you about the flow meter and the pipe instrumentation diagram is that for each type of flow meter, we have some standard conditions for strafe pipe upstream of the flow meter and strafe pipe downstream of the flow meter. In many cases, as standard, we use 5 pipe diameters downstream of the flow meter and 10 diameters upstream of the flow meter. But this is a rule of thumb. To have the correct dimensions, to have the correct size of these lengths, you must go to the technical sheets of the flow meter. For instance, here you can see typical arrangements for the installation of a thermal mass flow meter. This one is from ABB catalog. So you can see that depending on the kind of arrangement for the pipe that are designed by the piping engineer or designing the piping designer, and the fittings that you add to your pipe instrumentation diagram, the required length, strafe length upstream of the flow meter changes. For a situation where we will have a curve upstream of the flow meter, you can have, for instance, at least 20 times the nominal diameter of the pipe. So if I have a pipe with 100 millimeters of length in terms of diameter, the strength length upstream of the flow meter must be at least 2000 millimeters or 2 meters. So this is the way that we do plan design. We verify the catalogs of the suppliers and we see how to match the specifications or the requirements of the instrument. And this kind of information here, 20 nominal diameters upstream and 5 nominal diameter downstream of the equipment, we add this information in the piping instrumentation diagram, because the pipe engineer or the pipe designer will not look for this information in the instrument catalog. The responsibility to add this information in the pipe instrumentation diagram is from the instrumentation engineer or eventually from the chemical process engineer, if the chemical process engineer is also has the heart of an instrumentation engineer. That it is in my case where I am working too. So for a strafe pipe with a double curve, you can see that I need 40 nominal diameter, and for S curve I need 25 nominal diameter. So you will need to work closer with the pipe engineer to verify what the best fits for the process. Of course, that at preliminary stage, what you will do, you will add the information of the worst case. So you can see here from all arrangements, the worst case is 50 nominal diameter upstream of the thermal mass flow meter, and I will add that to my pipe instrumentation diagram. During the development of the project, you can talk, it's recommended to have a closer relationship with the pipe designer, with the pipe engineer, in order that depending on the kind of arrangement that they will consider for the process, that length can be minimized, can be lower. And with that has a much more cost benefits for the project. So guys, in this video we covered two important aspects of flow meters in your plan design as a chemical process engineer. The first one is to make sure what is a typical pressure drop of the flow meter when you are doing the heating and material balance of your process, especially if you are doing it in the process simulation software, because you can add an object like a manual valve to represent the pressure drop of your flow meter. And in the other hand, when you are developing your pipe instrumentation diagram, you must add the information of the strafe length upstream and downstream of the flow meter. At the early stages, normally usually we don't have the kind or the type of the flow meter that will be used. So you will have a hold information as a note. But if you already know what is the kind of flow meter that will be used, you must add what is the length upstream and downstream. If the project there is not enough space to have this kind of strafe run, you can add a device to linearize your flow, and with that reduce this distance. So this is it. If you want to know more about chemical process engineering and plan design, take a look in the next video that will appear to you right now.